GCSE revision video, and in this video we're going to be looking at circles, and we're looking at the relationship between the radius and the tangent. A tangent line touches the circle in one and only one place. The angle between a tangent line and a radius must always be 90 degrees. There is a distinct possibility that you might be asked to prove that on an exam. The proof of this circle theorem comes in two parts. The first part is that the shortest distance between a line and a point outside the line is a straight line that is perpendicular to the line. We can prove that the shortest distance between a line and a point off the line is perpendicular to the line by contradicting the opposite assertion. This is known as a proof by contradiction, where you start with a false assertion and then prove it wrong. So let's argue that there is a point on the line that is closer to the point off the line than the perpendicular. We can call this point A. Now let's argue that point A is the closest point on the line to point O. We can now drop a perpendicular to the line, which we can call B. The angle BAO is less than 90 degrees. If we draw a line the other way to point C, the angle BCO would still be less than 90 degrees. If we draw other lines further away, the angles B to that particular point and O decreases, so the largest possible angle between a point off a line and the line is 90 degrees. Line OB is perpendicular and line OA is from the point off the line to any point on the line. We can now draw a right angle triangle, which we can call OBA. Now let's label the line OB as A, and BA as B, and OA as C. Pythagoras' theorem dictates that C squared is equal to A squared plus B squared. And since B is bigger than 0, then C must be bigger than A. Therefore, point A is not the closest point on the straight line to point O. But we made the point that point A is the closest point on the line to point O. But we've just proved that that's not true, because you can always find a closer point, and that would be the perpendicular line. And that proves that the closest point on a straight line to a point off the line is perpendicular to the line. Now the second part of the proof states that the radius is the shortest distance between the centre of a circle and a tangent line. If there was a shorter point, then the line must penetrate the circle and must cross the circumference at 2 points, and therefore it would not be a tangent line, it would be a secant line. Since a tangent line only touches the circle in one and only one point, by definition any line other than the radius, which connects the centre to the tangent line, must necessarily go outside the circle and therefore be longer than the radius. Therefore, since the radius is the shortest point between the centre of a circle and a tangent line, and the shortest distance to a straight line is perpendicular to the line, the radius of a circle must be perpendicular to a tangent line. Okay, I hope you enjoyed that video. If you're taking your exams this year, I'd like to wish you all the best with your revision and all the best with your exams. Don't forget to like, comment and subscribe. And I look forward to seeing you in another video.